Write in the form of an interval if possible. Let's start. Right here we have the interval minus 5, 3 intersection 0, 5. Let's start by 0. Minus 5, this is minus 5. Let's start by the first interval, and 3. Okay. This interval, since it's closed, I'm going to denote it by the following. It's the same as the closed interval. And the second interval 0, 5 will be, this is 0, also it's closed till 5, and this is 5. We are looking for the intersection of these two intervals, and as we can notice, this is the red interval and the blue one is like that, and the intersection between these two intervals, as we can notice, is just this region, which is between 0 and 3. And we can notice that both 0 and 3 are closed. Then the answer right here will be 0, 3. For the second one, the same. I have 2, 6. Suppose that this is 0, 2, and 6. And this is the interval. 2 and 6 are both closed. And we have the second interval. This is the region I'm talking about. We have the second interval, which is 4, 8. 4 and 8. Also 8 is closed while 4 is open. Now the intersection between these two intervals is just this region right here, which is bounded between 4 and 6. Between 4 and 6. We can notice that 6 is closed while 4 it's open. Now the intersection between minus 2, 4 and 1, 5. Suppose that this is 0, minus 2 right here, and 4, this is 4. Minus 2 is closed, and also 4 is closed. This is the region. The second interval is 1, 5. This is 1 and 5. Okay. 5 is open and 1 is also open, and this is the interval. Now the intersection between these two intervals will be this region. We can notice that 1 is opened while 4 is closed. Again, from here we have the interval minus infinity till 4 and 1 plus infinity. Suppose that this is the 0, this is the 4. The first interval 4 is closed starting from here. So this is the first region or the first interval. Intersection 1 plus infinity. This is 1 right here, which is opened also till plus infinity. And we can notice the intersection as this region, which is between 1 opened and 4 closed. 5. We have between minus 1, 3 open. This is 3. For the first interval, 3 is opened. Then this is the solution or the region. And for the second interval, it's from 3 also opened till plus infinity. We can notice right here that there is no intersection between these two intervals. Even for 3, it's excluded from both intervals. Then the set will be phi. The intersection between these two intervals will be the empty set. Right here we have minus infinity 3 intersection. This is 3. The first interval is opened at 3. This is the first interval right here, and for the second interval it's closed. But also, yes, it's closed for 3. But also right here, if I'm talking about the intersection between these two intervals, 3 is included in the second interval, but it's excluded from the first interval. So there is no intersection between them, and the intersection also will be phi. Between minus 6, 3, this is minus 6 and 3, both are closed, and this is the region I'm talking about. This is the interval. Union right here, not intersection, 2, 5. This is 2 and 5. While I'm talking about union of two intervals, it means I have to combine all elements in one interval. And we can notice that it will form a continuous interval starting from -6 till 5, while -6 is closed and 5 is opened. 8, -4, 2. Also, I'm talking about union right here. Suppose that this is -4, it's closed till 2, which is open. Union 0, this is 0. Sorry, let's use another color. 0, which is also open till 5. Then the union of these two intervals will be starting from -4 till 5, while -4 is closed and 5 is also closed. -infinity till 2, which is open, this is 2, -infinity till 2. This is the first interval, and the second interval will be -3. This is -3, opened till 4. Also 4 is opened. The union of these two intervals will start from -infinity. It's a continuous interval till 4. Then it will be -infinity till 4, which is open, since right here I have an open interval.